Hello everyone. In this video, we are going to discuss the exploratory factor analysis. So the factor analysis structure actually all about how we are going to group the various variables, and when we actually apply that process, the factor analysis, the grouping of each variable actually signify a, a high correlation. And finally, when we identify the factors, we actually come up with the specific uh, interpretation of that particular factor. So in this video, we are going to see one example in which five big personality model will be used, where we will see that how different personalities are going to be grouped together. So what we are going to do is we will actually see that how different personality are grouping. For example, the introvert, extrovert, optimistic experience people, agreeableness, and consciousness personality. So through this process, we will see that how these personalities are grouped, and when we will perform the factor analysis, we will see that each personality will be capturing uh, high correlation within a particular type of personality, and at the end we will be interpreting that particular factor. So what is the process of principal component analysis, which is one of the technique in which we actually perform the factor analysis? So in this funnel, you will see that the original variables will be putting uh, through a complete process. We'll put into a complete process where we will see the transformation of these variables will take place, and we will actually generate various components of the factors, and the determination of these factors or components will be depending upon the amount of variance each factor is explaining. So the determination of the factor will be based upon how much variance they are capturing. So this is something important that we will just going to see while we will be performing the analysis. So finally, the principal components will be identified, and obviously within these components the variant the groups. So there are few important concepts which you should know that again when we'll be performing the analysis we will see these terminologies once again. So we need a correlation matrix that will display the correlation coefficient between variables to identify the relationships. So eigenvalue will be uh, we will see that which actually indicates the variance captured by each factor, and which is also guided by the retention decision. So on the basis of eigenvalue we will be determining that whether a component will be the part of the final component, or we need to reject that particular factor or component. So rotation matrix will also used. So in fact, we try to maximize the variance by applying the rotation matrix. So the main purpose is that we need to capture the maximum variance of each factor. So the rotation matrix actually tweak the model and try to capture the maximum variance within a particular component or factor. And again, this process shows you that the way through which we actually data analyze. The final goal is to interpret the factors uh, which are which are going to be grouped, and the process that they will be following is the correlation assessment, factor retention, eigen calculation, and rotation application. So these all important steps will be followed in order to come up with the particular factors. There are some important steps that we need to perform. For example, the KMO test that will actually tell the adequacy of the sample size. So before we apply the factor analysis, we need to see that the sample size that we are using in a particular data set, whether it is adequate or not. So for that purpose, we will be applying KMO test, and these are the different ranges. These are and or the different threshold points that we need to see that. So you can see here that below 0.50 KMO value actually is unacceptable. We need at least uh, 0.50 to 0.59 value in order to see that whether the sample size that we are using to perform a factor analysis is adequate or not. So you need to try to see that the KMO value should be greater than 0.70. And once again, look at these important concepts as we have discussed. So the correlation matrix that will be displaying the coefficient between pair of variables, because you will be taking, for example, if you are taking a questionnaire where the different items are given and you are going to group those items, so you have to see that the correlation between these items should be greater than 0.30 for and this amount of correlation will actually be appropriate for performing factor analysis. And eigenvalue that I just explained again, that indicate the amount of variance captured by each factor, and eigenvalue should be greater than 1, as typically retained as the explain more variance than a single variable. And rotation matrix is applied to enhance interpretability by maximizing the variance of factor loading across the variable. This helps in achieving a clear structure by making high loading. Okay, this is the dataset that we are going to use in performing the factor analysis. And here we are having the related items of Big Five personality model. So it is starting from here, and you can see here that these items are given in this data set, and these are actually grouped uh, in five different personalities. These items will be used to perform the factor analysis. You just go in the data view, and here you can see that group the five big personalities, and these are the related items. What we have to do is just go to the analysis, and uh, here we have to apply the factor analysis and dimension reduction, and just bring all these items in the variable section, and then go to the descriptives, check these tabs here, initial solution, and you have to check the coefficient, KMO, and inverse. And again, you know that the KMO and Bartlett test will be used to see the sample adequacy to perform the factor analysis. Just press continue in the extraction. So we are actually using the scree plot that graphically shows that how many factors you can extract from this data set. Eigenvalue set at the at greater than when that actually shows uh, the total variance explained by the each component of the factor. Just press continue. Go to the rotation. Here we are actually using the Varimax, as I've just informed you that this method will actually maximize the variance of each factor, because we are interested to capture maximum variance in each factor. So just check on the rotation resolution and loading plot, and just press continue. Go to the score and save the variables as regression, and also display the factor score coefficient matrix. And the finally in options, so what we want to do is we have to sort it each factor by size, and we want to express the coefficient values which are actually below 0.20. So in the final factor loading, the values which are below 0.20 will automatically will be removed, or these values will not be displayed in the factor loading score. So just press continue and just press again OK. So here we have the screen where we can see the correlation matrix, and like I said earlier, the correlation of each item should be ideally greater than 0.30. So this will actually ensures the factor loading will be we will actually achieve the factor analysis smoothly. So we just interested to see uh, the KMO and Bartlett test here, which shows the sample adequacy. As you can see here, the values greater than zero point 0.7, and it reflects the adequacy of the sample that we are having in this data set. And Bartlett test also significant shows the significant result. So it ensures these tests ensures that this data set will be adequate for to perform the factor analysis. The commonalities actually shows the amount of variance each item is explaining. Total variance explains it. This is something important here. This table shows that there are 15 components of the factor, but we have to take those factors or components which are having greater variance. So you can see here that the first factor is actually covering 26.503% variance. Second component is 13%. The next one 12.87%, and next is 8.83. So as you go down, you can see the amount of variance is decreasing. So what we have to do is we just have to take uh, the variance that is maximum captured by the factors. So you can see that the five factors are actually covering cumulatively 68.723% variance. So it means that finally we can say that in this data set we are going to take the five factors, because these five factors are capturing maximum variance, which is 68.723%. And the next scree plot, like I said earlier, that it will show graphically how much components of the factors you can take. So it's the elbow approach. You can see that after 5 the eigenvalues start decreasing. So ideally in this data set we have to take the components where the eigenvalue is greater than 1. So after this point then eigenvalue start decreasing. So ideally what we have to do is we should take 5 factors or components in this data set. And finally the rotated component matrix, it shows you that the grouping of the 5 personalities. So here you can see that the first component where the 3 items or 3 variables are loaded. The first one is the worries a lot, get nervous easily, for example remain calm in tense situations. So these components, 3 components, are related with the neurotic personality. So this is the first personality type that is actually covering the first factor. So the second personality, where you can see that these 3 items are covering in these items where this personality is actually extroverts. And you have noticed that the the components which are having loading below 0.20, automatically these values are not visible in this table, because we have already uh, actually set the criteria. We have to take the components values which are greater than 0.20. And the next personality, here you can see that this grouping shows the personality type who are openness to experience. So one important thing that you need to understand, that there are some factors which are actually uh, showing that the loading across various components. So there are various items which shows the loading across the component. So here what you have to do is you can actually remove those items in order to see what is the effect of after removing the items on the factor analysis final factor. Here I'm not going to remove those items, so you can check and you can perform the factor analysis by removing these items. Okay, so finally you have seen that in the factor analysis we are actually divide the variables into groups, and the main aim is to separate those variables that correlate highly from those that correlate less. So within groups, variables should be as highly correlated as possible between the groups, as low as possible. And in this case, we have just observed that how different personalities are grouped together, and on the basis of related correlation among the variables, we actually come up with certain factor